Hey everybody, this is Alex Merced from AlexMercedCoder.dev, GrokOverflow.com, DevNursery.com, lots of places. I try to bring you content. And if you appreciate that, please like the video, subscribe. It's much appreciated. Helps. The more you do that, the more people actually get to see this video, and the more people I get to educate and empower to be developers and do cool things and build cool stuff. But today's video, what I want to do is talk about promises. I've done videos on promises in the past, but I like to kind of redo these things every once in a while for like new features, to just, basically improve the quality of the last time I did it. So today what I want to do is talk about promises. Now, you probably have interacted with promises if you've ever used like the fetch function or a database library and had to use these things like .then and async await, and you're probably like, I don't understand what's going on. Well, let's talk about it. Okay, let's explain what's kind of going on. Okay, so what I'm going to do is I'm going to create a new file. I'm just going to call this promises.js. Okay, and bottom line is that JavaScript is a synchronous language, which means a single threaded language is probably more important. So the way to think about it is that your computer has a processor. Okay, and a processor can only really do one thing at a time. Okay, now your computer might be doing lots of things. You might have like 10 different programs open, but let's pretend you have a single processor. Now you have like multi-core processors, which is a little bit different. So think of each core as what I mean by one processor. Okay, so if you have a single core processor, that processor can only do one thing at a time. Now, really fast processors can do that one thing at a time really fast, but it can only do one thing at a time. But again, I might have 10 programs open, and it's not going to just let one program run and block and stop everything else. So typically what happens is you have multiple threads. Okay, each thread represents one thing that is happening, okay, or one chain of events. So typically what your processor is doing is just saying, okay, hey, let me do the next thing on this thread, let me do the next thing on this thread, let me do the next thing on this thread, let me do the next thing on this thread. Okay, so in order for computers to handle so basically when we talk about multi-threaded things, okay, that means you create multiple threads to say, hey, let's do some of the work on this thread, let's do some of the work on this thread. You're still using the same processor. It's just taking turns between the different threads on what's the next thing to do in that thread. And then when we talk about multi-core, well, that's when you actually have multiple cores. So, if you have two cores, you can do two things at the same time, and then each of them have a bunch of threads that they're passing around. Okay? So this is where we get into what's the concept of asynchronous and concurrency. I'm not going to get too deep into concurrency. So that whole multi-core thing is more about concurrency. But the idea is that when you write a JavaScript file, so in this case, if I just write console.log 1, console.log 2, console.log 3, and I were to run this file, this is all running on the same thread. Okay, technically each shell, so you notice how I opened up this terminal or shell environment, each terminal is essentially a single thread. Okay, so if I were to do a node promises.js, okay, that was all single thread. And notice I could not do anything else in my terminal until that process was done, because a single thread can only handle one process at a time. Okay, for me to have multiple processes running at the same time, I would need multiple threads. Okay, so bottom line again, a JavaScript thing is a single threaded. So it's basically everything's still happening in a certain order on that same thread. So anything that's happening in this file is going to still be on the same thread. So theoretically, let's say I do this. Let's say I do let's say I do a set timeout. Set timeout, and we'll just console log 4. Okay, so we're going to say, hey, I'm going to console log 4, and we'll do that after 4 seconds, 4,000 milliseconds. Okay, if I were to run this, so you see, like, notice there's no prompt because it's waiting. My current script is still running, and after the 4 seconds are over, it logs 4, but I couldn't do anything else. Okay, so that thread that's what we refer to as blocking. Basically, because that thing is doing something, my thread, at least as far as the shell is concerned, has been blocked. Okay, I couldn't do anything else. Now, in terms of that single JavaScript process, the JavaScript process itself, so again, there's the shell, and then inside the shell, we have the JavaScript code running. Now, when JavaScript is running, in order to allow you to do multiple things, it does what's called an event loop. So when you do things like a set timeout, so essentially think about it this way. JavaScript reads your file of code, does everything in order, but then what it'll do is it'll create these separate queues of other things to do that it'll do at the end of a loop. Okay, so for example, if I added another console.log, after this, let's watch what happens. Okay, node promises.js. Notice the console log of 5 still happened. Even though we're waiting 4 seconds for the console log of 4, the console log of 4 does not block the JavaScript code from running. Okay, this is kind of how, it doesn't mean there was another thread. So it doesn't mean, hey, this 5 was able to log because we opened up another thread that logged the 5 while the 4 was just waiting. What it does, it uses the event loop. So what it did is that it said, okay, hey, let me put this in this line for later. Okay, and then at the end of the loop, I'll come back to it. But let me go do everything else first. Everything else that's not queued up for later. Okay, so there's these queues or lines of things to do after everything that can be done now is done. Okay, so basically anything not wrapped in, let's say, a set timeout. Okay, or a set interval, anything like that. But again, the main thing to notice is that, see, the 5 still logged. It didn't wait for the 4 to log. Okay, but it's still a single thread. It's still like just one line of task of things to do. The way JavaScript handles it is that, hey, when it notices the set timeout, and that's not going to happen for a while, it just queues it up in a line somewhere else within what's called the event loop. Cool. Okay. Now, this is basically how using these kind of set timeouts was the kind of the way we would handle sort of asynchronous code in the past. So basically, if anything I needed to do that I didn't want to block my program, I would put here. Okay, I would put in a set timeout. And then that would get queued up to be done after everything else is said and done. That's okay, but not necessarily very intuitive. So what they did is they created a structure called a promise. A promise more explicitly and semantically basically says, hey, there's something I'm going to do. It may not be done yet, but when it is done, let's get back to it. Okay, I will give you the thing when I'm done. Okay, so a promise is going to work like that. So when a promise happens, it will not block my code. Okay, so console.1, console.log2. And the way a promise works is basically what we do is we create a promise object. So I'm going to create a variable for my promise. It's going to equal a new promise object. And a promise object is essentially a function. Okay, it's essentially a function that is passed two functions. So this callback in here is going to get two functions. Where's it getting it from? It's getting it from JavaScript. Okay, it's going to get a resolve function and a reject function. Okay. Cool. So the idea is basically the promise is either going to resolve or it's going to fail. You can even do it like pass or fail, however you want, whatever words you want to call those functions. Okay. So in this case, I'm just going to resolve it in a way that's always going to work. So I'm just going to say resolve. Okay, 3. Okay. So essentially what's going to happen is that this promise, when this function resolves, that's when the process is completed. Okay, so what I will do is actually, I'm going to wrap this in a set timeout. So I'm going to say set timeout. Okay, when this is all said and done, it'll resolve that to 3, and it'll do that in 4,000 seconds. Okay, so it'll basically resolve the promise with a value of 3 after 4,000 seconds. So if I do that, and I console.log If I console.log the promise, we'll see what we get with the promise. Okay, and then we will go with that. And then we'll say console.log 4. Okay, so let's see what happens when I log the promise first. Okay, so notice it says 1, 2, 3, and it says promise pending. It means the promise did not resolve yet, right? Because technically the 4 seconds hadn't passed. Okay? But if I look at this, again, take a look at my prompt. So this thing right here, that's my prompt. Notice it won't show up right away because the JavaScript still has to play out. The 4 seconds still have to happen. So you see it's like kind of blocked because it's waiting for that promise to resolve. And once it resolves, it's done because there's nothing else to do. So what if I want to access that resolved value? Well, promises have a function built into them called .then. So it would be like promise.then. And then in here, I can pass a function that receives the value, whatever the value that this promise resolves. So whatever gets passed to this resolve function is what this .then receives. Okay. And then basically what happens is I can do whatever I want with it. So I can console.log 3. Okay. Okay, and then you'll see eventually we'll log 3. You see the promise resolved and it logged 3. Wonderful. So see the promise, the .then allows me to specify what I want to do once the promise is resolved. Okay. So if you ever worked with Fetch or Mongoose or any other database library where you had functions that return the promise, under the hood of those functions, they return you a promise and then they have some sort of, logic for when that promise resolves or rejects. So you're just saying, hey, when that promise resolves, this is what I want to do with the thing that it gives me back. Okay. That's all that's happening. Okay, now what if I were to name this to 0? So if I were to do the 0, that means it would immediately resolve, right? So technically, the promise should resolve in time for me to do 1, 2, 3, 4. Well, let's see. It still did 1, 2, 4, 3. Why? Well, the reason is once a promise exists, that is still queued up to the end of the event loop, which means everything that isn't delayed, even if you delayed it, even if it gets immediately resolved, it is now in that queue that occurs depending on how you use it, either at the end of the current event loop or before the beginning of the next one. It's going to happen in that queue, that series of events. So essentially, this console log will still happen first because this has not been queued. Okay. By the fact that, so again, if I did this, like let's say I just get rid of the set timeout, because the set timeout muddies the waters a little bit. Okay, let's get rid of the set timeout and still just resolve this right away. It's still gonna log me the same result, because the way promises work, that promise is also queued at the end of the event loop. Okay. So again, this, which is not queued, this is not queued, this is not queued. Okay, there is a slight difference between what happens with set timeout and set interval. You're queued to the end of the event loop, and I think promises you're queued to the beginning of the event loop. Let's test that out. So let's do this. Let's do a set timeout, and let's console.log 4 in here. So function that console.logs 4. Okay, and let's give that 0 milliseconds. Okay, and then this will console log 5. So if the set time, this will confirm either way. So node promises JS. Okay, now let's take a look, and that kind of confirms it. Well, we'll do it two ways. So again, so we see here that first, the 1 got logged, of course, because that's not queued up. 2 got queued up. But then we have a set timeout and a promise. Again, even if they get immediately handled, so even if the set timeout has a timeout of 0, even if the promise is immediately resolved, they still get queued to the end of the event loop. So they're still going to happen after anything that's not queued happens. So in that case, this console log happens here. Okay, so we see 5 as a third console log. And then the promise plays out first, or the .then plays out first. Okay. And the set timeout plays out second. Okay, so let's see what happens if I move the set timeout to before we create the promise. Okay, do I get the same result or does it switch? Let's find out. Okay, we get the same result. So even though this got queued up first, whether it got queued up first or second, it still ended up happening last. So what this determines is that that means the queue that the promise is in happens queued at the end. Queued at the end of the event loop, which is why it happened first. Okay, because even though this got queued second, it's in a separate queue. So there's two queues. There's a queue at the end of the event loop and there's a queue at the beginning of the next event loop. So promises are queued at the end of the event loop, and the set timeout is queued to beginning of the next event loop. Okay, now is this going to matter most of the time? Oftentimes for like your basic use cases, this distinction isn't going to matter, but it's good to know in case you have some weird behavior that you're not quite sure if you understand. Okay, so now you know. Okay, cool. So that's what a promise is. That's all a promise is. And again, if I want to create some sort of logic that says, hey, in this situation, a promise fails, I could then use this reject function. So I might just do some sort of if statement and say, hey, if this is true, resolve. If this is false, then reject. And then I would just use the reject function and pass like an error to the reject function. And how would I handle the reject? Well, then I would just do a promise.catch. And this would get the error. And then I'd be able to handle the error. Okay. So essentially, the promise has a .then function and a .catch function. Okay, but you can see, like, writing these .thens and these .catches aren't the most fun thing in the world. Okay, so which is why there is what's called async await. Okay, now async await allows you to clean up the syntax. So let's see here. Let's do this. Let's create two functions. Let's just create a function that returns a promise. Okay. We just want an arbitrary promise just to kind of give an example of this. So this will just return a new promise object, and which will have a resolve or reject, and it's just going to resolve to 3. Like, keep it real simple. Okay, so it's just going to resolve to an arbitrary value of 3. Okay, now I'm going to write a function that handles that promise. Function. Okay. So when we're using the .then syntax, it would look something like this. I would say, hey, I want to, I would invoke the function, like this could be like fetch or one of the mongoose function that returns a promise. And then I could chain off of that and say, hey, .then, let me, take that value and console.log the value. And this works. But again, a little kind of hard to read. Okay, a little hard to read. Okay, so if I then, again, if I run that function, handles promise, so we can see the result. Node promises.js. It works. See, the promise resolved, and I log the value from the .then. But again, a lot of people still found this, well, this was better than using a bunch of callbacks, which was the old solution where you would have to have these set timeouts, and you would just kind of keep, or a set interval, and you would just keep looping and checking until something was either false or true, and then you would kind of handle the problem. What you can do now is I can use what's called async await, much easier than doing this. Okay, now if I make the function asynchronous by using the async keyword, okay, before the definition of the function, it tells this function essentially that it'll always return a promise. Okay, we'll prove that out in a second. So in that case, because of that assumption that this function will always return a promise, it'll take whatever you return and wrap it in a promise. In that case, I can now do this. Okay, I can now in this case say, hey, const result equals await returns promise. And the idea, the always assumption with the word await is that whatever is after the await is something that returns a promise. So then what it does, it's going to pause the function right there. So it's not pausing your whole program. So the rest of your program will still run. So any unblocked code will continue. but it'll wait for the promise that this function returns to resolve. And once it resolves, it's just going to assign the value to here. So in that case, I don't have to do a .then because the 3 is going to be inside this result variable. And then I can console.log 3. Okay, and then that will work. Okay, awesome. Okay, so you see that worked out pretty nicely. But again, we're still working with promises, and promises get queued. So even if I were to put over here, let's say console.log 4, look at the order these things will log. The 4, then the 3. Because again, we're still working with promises across these functions. Promises get queued. This console log isn't in the context of a promise. It isn't in the context of a set timeout or a set interval. So it doesn't get queued. So it gets executed right away. Okay. So at the end of the day, when you're using async await, you're still just working with promises and doing .then. The only difference is that the await replaces the .then. It just makes it look nicer. It makes it look easier. You're still doing the same thing. Okay, it's the same thing as me doing the .then. The other thing I want to point out is, again, this function returns a promise. So if I were the console.log, the return value of handles promise. So let's say I return the result. Okay, and again, we see here, if I console log, oh no, why didn't I console log 3? I want to console log the result. Okay, so we see here, we're going to say, hey, result from the function. Okay, and then here we'll console log result from outside the function. Okay, because you see here, I'm returning result. So essentially, when I run this function, that's going to return result. Okay, well, let's see what I get. Okay, so notice that when it returns the result from outside the function, okay, it's a promise. Because again, once you use the async keyword, doesn't matter what you return, the return value is always wrapped inside a promise. That's how it's able to... That assumption is what allows you to have this nicer syntax. Okay, so that's just the one thing to keep in mind when you want to use async await. You can't return just the raw value. Okay, you're always returning a promise. Same thing if you were to return a value from a .then. So for example, see this .then here, or not? Well, let's say I did a .then. That also would return a promise. Okay, there's no way to, once you get into promise world, you're stuck in promise world until somebody .thens. Okay, but just keep that in mind. The minute if I take away this async keyword, and actually let's do this. Let me just actually comment out this. Let's not even work with a promise. Let me just return 1. That's literally all this function is going to do. Return 1. If I just return 1 and I made the function async, okay, watch what happens. Okay, I still got a promise with the value of 1. Okay, it still is a promise. But if I take off the async keyword, now it logs the value of 1. So literally, just by adding that word async means that anything that functions returns will get wrapped in a promise. Okay, this is an important thing to be aware of when you're using it. So, because a lot of times people will make their functions async, they return the result, they're thinking, oh, okay, cool, I'm going to have the thing. And no, it's still a promise. So I would still have to, like, if I wanted to access the value outside, I would still have to do like my own .then here. And then be like, okay, the value console.log the value. Because again, this, regardless, because it's an async function, whatever this function returns will be wrapped in a promise. So then I can .then off that promise. So it really just comes down to knowing what your functions return. When you work with a function and you know it returns a promise, and how would you know how to do that? Documentation. Then you know that you need to either you need a .then to say, hey, what happens when this promise resolves, or a .catch when it fails. And if you don't want to do that, you can create an async function and use async await from within that function. Now, a cool thing you can do now, if I were to make this, if it's an ES module, okay, so in that case, make this an ES module, I would just change this to an MJS file, module.js. In an ES module, you don't need to, you can actually, I'm pretty sure you have top level await, and we'll test that out. Top level await means I don't have to use an async function to use await. Okay, so I could do this. Okay, so if, let's say I have this promise that just automatically resolves, I can say const result equals await new promise. And then I can console.log result. And I think you can do this in the browser now too. Again, assuming it's an ES module. Okay, it has to be an ES module. It has to do with just the way the files are treated by the engine. My guess would be just that each file is treated as sort of its own function scope that is an asynchronous function. So essentially, the file would export things kind of, I won't get too deep into it. But if I run that file, oh, didn't like that. Let's see why. Cannot find module. Oh, because I put JS. So let's do MJS and see it works. Okay, instead of returning me the promise, like if I take away the await here, I get back, I'm going to log the promise, not the 3. See, I'm getting the promise wrapping the 3. Okay, and notice how like a promise object, all it is a wrapper around the value you don't know yet. That's literally all it is. A promise is just a wrapper around a value you don't know yet with functions to access that value once it is known. That's what the .then is. It's just saying, once I know what this value is, what do you want me to do with it? Okay, this pattern in programming of, wrapping values and then having functions to work with the value inside the wrapper is also known as a monad. Okay, in case that ever comes up. Okay, so yes, that's all it is. A monad is just a thing that wraps a value and lets you do things with it. This is one example, what's called a promise. There's other types of values, or there's other types of monads out there. Okay, for example, like an error, in a sense where like an error object could be something that wraps the value, which is the message of the error. That's not exactly a monad. It's some, because you're not using a function to access the message, but it is a wrapper. And I'm trying to remember what the term for just a pure wrapper is, but you get the idea. The point is, a promise is a wrapper around the value you don't know yet. Once the promise resolves, meaning you know the value, the .then dictates what you can do next. And once if it fails, like the value never comes, then you can use a .catch to say, hey, this is what you do if you don't get the value back. Okay. Yes. Okay, so to show one more example. Okay. Or actually, I think we spent enough time on this for now. There's a lot we can say about promises, but hopefully this gives you a better idea of how to use async await syntax, .thens, and what are promises. So again, my name is Alex Merced from AlexMercedCoder.dev. Have a great day and enjoy. Make sure to like, subscribe, and share the video. I'll see you all later.